Hi everyone, this is Mr. Spengler. I hope this Monday finds you healthy and happy. It looks like it's going to be a beautiful day outside. Hopefully you have a chance to get out and enjoy the day. But remember, social distancing is super important right now. We're a hot spot here in Cold Spring, and you should stay distant from your friends and just be really careful out there because it's hitting really big time here. I know it was 2 weeks ago or 2 months ago where it was hitting in Minneapolis, but it's hitting here now. So respect COVID-19 and socially distance. Anyway, our topic today is humidity, and I'm going to give you a few notes. If you want to write those down, that would work. Otherwise, I'll post this presentation. You can use this, but when you're done watching it, or as you're watching it, there'll be a form, or basically a worksheet that you fill out, and the questions will follow along with my notes. So today we're going to talk a little bit about humidity. And humidity is a really important concept. And it's basically just, hey, how much water is in the air? We've been kind of neglecting that and what we've been doing. So today we're going to talk about moisture in the air. So you might recall this graphic of uh, nitrogen making up most of the air, oxygen making up a smaller percentage, and then smaller amounts in other gases. Well, this was a bit of a lie in that we weren't telling you the whole story because there's no water in here. Why didn't we put any water vapor in here? Because of course there's water vapor right now as you're breathing some vapor into the air. So why did we neglect that? Well, we neglected it because it turns out that depending upon a given day, the amount of moisture in the air changes. So this is the percentage of gases in dry air, air without any water in it. But that doesn't normally happen. So we weren't trying to lie to you or anything like that, but it changes so much from day to day. During the day today, the amount of moisture in the air will likely increase as it warms up. Okay, and from place to place, in certain places there's going to be a lot of water vapor, and other places there's going to be less, and time of the year. So all those things make it difficult to give you a nice pie chart like this when we're talking about or when we include humidity. Okay, so today we're going to add water vapor with our notes. Simply put, the amount of water in the atmosphere is called humidity. And I think we all have an idea what humidity is, but it's a measure of the amount of water in the air, and we can do it in a number of different ways. It turns out that as air heats up, it can carry more water. And in the winter, it's said to be dry because, and you might experience hangnails, dry skin, and things like that because the air outside is so dry when we bring it in and heat it up in our school, especially, it's especially dry and our skin dries out. So, anyway, humidity is a measure amount of moisture in the air, and we can measure it in a few different ways, which can be confusing. That's the topic today. We can talk about absolute humidity, and that's what Amplify likes to use. Relative humidity, which is often used by weather forecasters and things like that, and dew point. So we'll talk about each of those. So, as I said, Amplify uses absolute humidity, and that one might be the easiest thing to get your mind around. It's the actual weight of water in a parcel of air. So this is a picture, a screenshot of something Amplify had in the sim. So this air parcel has 31 kilograms at a certain temperature for a certain volume of air. And scientists measure it in a meter cubed of air. So that's a cube by that's a meter by a meter by a meter. Um, and this is probably supposed to be a kilometer cubed, which is or cubic kilometer, I should say, 1 cubic kilometer, which is 10 meter by 10 meter by 10 meter um, parcel, and it would weigh quite a bit more. But anyway, absolute humidity is just the weight of water in a certain volume of air. And that's what Amplify uses, but it's rarely used otherwise. Now, a more useful uh, measure of humidity is relative humidity. And that's when they say relative, that means there's a comparison going on. And what we're comparing is how much water is actually in the air versus how much water could be in the air at that given temperature. So if you look at this graphic, there's a certain amount of water vapor here. And notice this amount of water vapor is the same. Okay? So because the circle is the same size. Well, at 10 degrees, that amount of water vapor might be all that the water can hold. But as the temperature increases, the air has a capacity to hold more water. So if you notice, the relative humidity decreased. And at 30 degrees Celsius, it's even less because it could hold more. So typically, on a day like today, there may have been some water vapor on the grass, which we call dew. That means in the morning we are at 100%. But as it begins to heat up, there's a certain amount of water in the atmosphere. We could hold more water, so the humidity drops. Um, does it the amount of water vapor drop? Not necessarily, but the percentage that it could hold is dropping. And the formula for relative humidity is, hey, how much water is it holding versus how much water would it hold at saturation when it's 100%. And you just divide one by the other and multiply by 100%. All right? So relative humidity is a real common one. They'll say the relative humidity is 80%. On a warm day, that's a lot. Okay, that's a whole lot. But on a cold day in the middle of winter, that's kind of meaningless. So better than relative humidity is really dew point. All right, so dew point is the temperature at which the air is saturated with water and condensation begins. So if you have a high dew point, that means at a high temperature, water is going to come out of the air. You might notice on a hot summer day that's really muggy or really humid, um, your toilet might be all sweaty on the outside. There's condensation on it. That's because the water in the toilet tank, is cooler than the dew point, and dew or moisture forms on the outside of the toilet. And that also happens on glasses and things like that if you have ice in them. But dew point gives you a real idea of the comfortability of the air. The higher the dew point, the more moisture is in the air and the less comfortable it is. And one important thing is the dew point's never going to be higher than the air temperature. It can be equal to the air temperature, which would be 100% humidity, um, and um, but you can't go higher. Okay, so I use the word muggy. Muggy just describes the air when it's warm and there's a lot of humidity in the air. We perceive that uh, as uncomfortable because, well, number one, it's harder to breathe air that's got a lot of water in it. It just feels heavier. It's actually lighter than air, but it's more viscous and harder to breathe in. So that's one aspect. And the other aspect is you might feel like you're sweating more, like this person sweat through his shirt. And it's not really that you're sweating more, it's that sweat isn't evaporating because the water in the atmosphere is almost to its saturation point. So your sweat has nowhere to go. So it stays on you and it doesn't cool you because it's not evaporating. So on a muggy day, your sweat isn't doing its job. It's not evaporating and taking extra heat with it. So if the dew point's below 50, you're comfortable. As it approaches 60, it's getting pretty muggy. Over 60, around here, we consider that pretty unpleasant. If it's in the 70s, it's really bad. I mean, that's here in Minnesota, that would be terrible. And if it's over 80, which I don't know if it ever gets that high in Minnesota, it's just you wouldn't want to be outside. You'd have to be somewhere where you're cooler in water. I don't know, in air conditioning. So that's dew point. How do we measure humidity? Well, it's a little bit more complex, but if you think of it this way, it's not too tough. And we're going to be doing this tomorrow. We'll do a lab. And so humidity, to measure it, what basically you need is two thermometers. One thermometer is just a normal thermometer. The other one's got a little cloth on it that's wet. And as you know, if you're wet, let's say you were swimming and you come out of the water, it feels cool right when you get out of the water. That's because the water that's on you is evaporating and it takes heat away from you. So basically this thermometer represents wet U and this represents dry U. And if you sling it around, it's on a handle and it spins around, and you spin it around for a minute or so, and then you check the temperatures, and you'll find out that the temperatures won't be the same in both of these. If it is the same, that means no water is evaporating here, which means you're at 100% humidity. So if you look right here, if there's zero temperature difference between the two thermometers, you're at 100% humidity. Okay, so when you spin this around, you use this chart and you read the temperature of the wet one and the temperature of the dry one, and you look at the difference. The greater the difference, the drier the air. Okay, so this is what we'll be doing tomorrow. So now what I'd like you to do is go ahead and click on the link for the worksheet form for this, and we'll all be ready for the lab tomorrow and understand what's going on in the lab tomorrow. Thanks a lot and have a great day, and don't forget the importance of social distance.